email everyone. Well, I'm recording this, so thank you for being here if you are here. Here's a quick video of what is a conic section.
Sections. In this module, you will learn about.
So, simply enough, you have this weird cone shaped thing. That's why we call it conic sections. When we take a section of it and slice it like this, you make a parabola.
Conic sections. When a straight line intersects a vertical line at a fixed point and rotates about that fixed point, the surface obtained is called a double right circular cone. A double right circular cone consists of two cones joined at a fixed point called the vertex. What remains fixed is called the circular base to the vertex.
Okay.
True surface of a between the generator and the.
Okay. So that's a parabola as it slices. What we're going to explore today is what happens if you slice it
different types.
Like these so. That is something else. If you see the shape that is formed there, looks like a circle. It's actually called an ellipse. So hence the name of today's lesson, the ellipse. So share whiteboard. Okay. Where's my thingy? There it is. So did you know that a circle is the same thing as an ellipse? Those are actually the same shape. Of course, it doesn't work the other way around. An ellipse is not exactly a circle. Kind of like a square is a rectangle, but a rectangle isn't a square. It's just part of its family. So, actually, I'll keep that on there. Ellipse. We have two types, that one and that one. And an ellipse has an equation. Looks awfully familiar, doesn't it? That looks almost like a square. However, no, excuse me, not a square, a circle. But this is going to equal to 1. And these are actually being divided by an a squared or a b squared. That's the equation of ellipse. In this case here, let's look at an ellipse itself. Here's an ellipse. Wow, that is the worst ellipse in the world. Is there a way I can put shapes here? Ooh, I can. Ooh, let's just do that. Don't do that, Mr. Baron. Wait. Undo. Oh my goodness. Oh, yeah, we could do that. Nice. Okay. Ah. There we go. Cool. That's an ellipse. Now, if you look at all the letters here, HK is still the center of the ellipse. Okay. Now, this has a couple of other things. This is going to be the major axis. And this is the minor axis. Basically, the larger and smaller side of, or how it's positioned. This would be a horizontal ellipse of where the major axis is horizontal and then the minor axis is vertical. This would be a horizontal ellipse. This is actually A, and this is negative A. This would be B. This would be negative B. This is a typical ellipse. This is always true. A will refer to the major. B will refer to the minor axes. There's also other things. There's also one other thing that is true about this ellipse. To draw an ellipse, there are two magical dots that are invisible. We called it something. Oh gosh. For parabolas, we called this magical dot the focus. That was the homework that was supposed to be due yesterday. Also, an ellipse, these are also called focuses, but though there's no such thing as a word called focuses, we call it the foci. C refers to the foci. That is more than one focus. It has two focuses, but in English, we don't say focuses. These are called the foci. And that would be negative C. That's C. But if you notice in your equation, you don't even know what C is. We'll get to that in a second. Now, this is actually for a horizontal ellipse. I know this is horizontal because the A is under the X. This tells us this is a horizontal ellipse. The other equation looks exactly the same thing, except that now this would be B and this would be A. Now, this is a vertical ellipse. Keep note, A is always the major. In other words, A is always going to be bigger than B, because it would make sense, because that would represent where the bigger part of the ellipse is, going either left and right or up and down. So we could sketch one of these real quick. Let's go x squared over 25 plus y squared over 100 equals 1. And sketch. It's pretty simple. You should be able to determine immediately, hey, is this going to be a vertically, an up and down hot dog, or a wide hot dog? Just by the fact that this is the bigger number tells us this y represents the major axis. So then this tells me that my ellipse is going to look like this. Whoa. Technology, come on. That's pretty good. Boom. Now, who can type in real quickly, how tall is this? What is this number right there? Based upon everything on the board right now. What is this right there? What is that? It is 10, which makes this negative 10. All right, Hanson, what's this and what's this? Cool. 5 to the right, negative 5 to the left. We could see that B is 5, A is 10. We still have one other thing to find, something called the foci. I need to know what C is. This is called the foci. There is an equation and it's always true. So I'm going to write this again over here. A is the major axis. B represents the minor axis. C, the foci. There is an equation to find this every time. It is C is equal to the square root of B squared minus, no. A squared minus B squared. That is always, always true. So really, you could keep these. Oh God, you could. Oh wait, let's use our awesome technology here. You could keep this all in one box right here, like so. You have the two equations of a horizontal ellipse, a vertical ellipse, where A is the major axis, B is the minor axis, C represents the foci. And we could find the two foci with this equation. So let's find our foci over here. C is equal to the square roots of 100 minus 25, which gives us the square root of 75. Roughly, where's my calculator? I don't know the square root of 75. 8.66. So plus or minus 8.66. Which makes sense. That means the foci is right about here. And the other one's right about here. I'm just going to write C and negative C, which we know down here. It's pretty simple. Now, here's a question. What would be true about a circle? What do you think is true about a circle, about A and B, if we have a circle? Think about it. If it is a circle, what would be true about A and B? Yes, that's right. A and B would exactly be the same. In fact, wait, I'm going to erase this. Or I'll just do this. For a circle, as you said, they would be the same. It would be x minus h squared over a squared plus y minus k squared over a squared. This looks awfully familiar. If I multiplied everything by a squared, we get the original equation of a circle, except the fact that instead of using r, it's a squared, which a represents not only the axis, but it also represents the radius. But an ellipse doesn't have a radius because it's not the same all the way around. This is circle only. Okay. Graph the ellipse. I don't even know if ellipse has two L's or one L. Graph the ellipse. Oh crap. Let's go x minus 3 squared all over 4. No, that's too small. 16 plus y minus plus 1 squared all over, we'll go 4 here, equals 1. Immediately, this tells you what type of ellipse this is. The bigger number is under the x, which tells us this is a horizontal ellipse. And I can quickly draw that. So it would look roughly like this. Or does it? What is my huge mistake I did? What is the big mistake? What is wrong with this? What is wrong with this? What's wrong with it? The center is not correct. Thank you so much. The center is not 0, 0. This should actually be centered at 3, 1. Like so. Oh gosh. Okay. Which tells us that this now tells us that if this is 16, so then it's going to go 1, 2, 3, 4 to the right, because then A is 4, B is 2. We still don't know what C is, but we know C is defined to be 16 minus 4, the square root of 16 minus 4. So we have our major, we have our minor, and here is our foci. So it's going to go to the right 4 and to the left 4. So I'm going to go 1, 2, 3, 4. And it's going to go up 2 and down 2. And hopefully this works. You think it's going to work? Oh, that's pretty good. Look at that. Oh, no. Wait. There we go. Yeah, that's good enough. Can I still move this? Oh, shoot. Yeah, there we go. And that's good enough. Okay. We're also going to figure out what the foci actually are. That's the square roots of 12. Damn, I hate using my cell phone to do this. Okay. So the distance of the foci is plus or, oh gosh. Plus or minus 3.46. The square root of 12. Now, I think in the book it wants you to find the actual coordinates. So we know this is 3, 1. So that means that these two coordinates should be this is 5, 1. No, that's not 5, 1. This is 5, 1. This is negative 1, 1. Again, I'm just adding 4. I'm adding 2 and oh, I'm still wrong. Crap. No. 3, 3. I'm adding 2 up and then subtracting 2 down. 3, negative 1. Okay. The axes here going right, we're going to add 4 here. This is 3, 5, and then subtract 4 here. This is 3 minus 4 is negative 1. So this is, oh my God, I am messing up hardcore here. This is 5, 1. No, 7, 1. Wow. Add 4 to the x, subtract 4 to the x. Gosh, I'm sorry if you are writing this down. Okay. Subtract 4, that's negative 1, 1. You can also find the location of the two foci. In this case here, I would take the vertex. We would add 3.46, comma 1, and h minus 3.46, comma 1. This is the foci, the location of the two foci. Although I did mess up a lot, I was getting really mixed up with what I'm adding to. Should be pretty straightforward. Just follow the definitions and understand what type of ellipse it is and where it's centered at. Let me look at the book real quick. Okay. Okay. That says rewrite the ellipse, then find all the vertices. Okay. 4x squared plus y squared equals 36. We say rewrite the ellipse here because, hey, this ellipse doesn't look like the equation we want. In fact, this equation is supposed to equal to 1. So the first thing we're going to do is do what? I want it to equal 1. And I also want the x's and y's to be all alone. Okay, I'm running out of time here. We're going to divide everything by 36. Okay. By doing that, our new equation becomes x squared divided by 9 plus y squared divided by 36 equals 1. This tells me everything I need to know to finish the rest of this question. The center is h is 0, 0. So from there, you could tell me all the vertices. In fact, this is going to be a vertical ellipse. It doesn't say to sketch the thing, but we can real quick because it makes it easier. Oh gosh. Boom. This would be 0, 6, 0, negative 6, 3, comma 3, 0, negative 3, comma 0. For the point being, B is 3, A is 6. We don't care about C. It's not asking for the foci, just the 4 vertices of this ellipse. The vertices is basically the coordinates of the major and minor axes. What about this? X squared plus 4y squared plus 6x minus 8x plus 9 equals 0. Mr. Viernes, that's a circle. Ah, are you sure about that? Well, Not too long ago, you were given a homework 2 weeks ago of how to change this thing into standard form. Oh, no, 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 no. This is standard form, and we want to rewrite it into graphing form. All we know is that this could be a circle. But what's to stop it from being an ellipse? It could be an ellipse. If it is a circle, it's definitely an ellipse. Well, what we're going to do is remember what we did 2 weeks ago and do completing the square twice. We're first going to group up the x squareds and the 6x's together. And I'm going to group the 4y squared with the... I wrote this wrong. What did I write wrong? Oh, this should be 8y. Okay. This is 4y squared plus 8y, and this is going to equal -9. Please check back on that lesson if you never did it or don't remember. So the plan now is to go ahead and complete the square twice. Now, there is something wrong here. I don't like this 4 here. So before we complete the square, I'm going to factor out the 4 to get a y squared plus 2 y equals -9. And this is still x squared plus 6x. So we're going to add things twice. I'm going to do that in, let's do it in blue. Over here to complete the square, I'm going to add 9 here and add 9 here. I'm going to add 1 here. I'm going to add what over here? Ooh, I'm going to be so happy if someone guesses it. Here we added 9, 9. Here I'm adding 1. Do you remember what I'm actually adding over here? Come on, one person. There's 4 or 5 of you here. 4. The 1, although we normally put 1 over here also, the 4 that we factored out gets multiplied to that. This 1 gets multiplied to the 4, hence we add 4 over here. So we add 9 here, add 9 here, add 1 in here, but add 4 right here. Okay? We've completed the square. This is going to equal 4. -9 plus 9 plus 4 is 4. This is going to equal to parentheses x plus 3 squared plus 4 parentheses y plus 1 squared. Take a look at that. That looks awfully like a circle. But it isn't. This equals 4. So what we need to do now here is divide everything by 4. Because we want it to equal 1. Because it says rewrite the ellipse. The ellipse must equal 1 in this form. So we get x plus 3 squared all over 4 plus y plus 1 parentheses squared all over 1. You don't need to put the 1 there, but I'm going to put the 1 there because we can actually see where the vertex, what the axes are. This is an ellipse centered at -3 and -1. And I noticed that A is 2, B is 1. So it's going to go up 1 and down 1. That point is -3, -2. This is -3, 0. It's going to go right 2 and left 2. Oh boy. This is -5 comma, -1. This is -1, comma, -1. And there's 4 vertices. That's a lot of work, but this should be familiar because we did this 2 weeks ago in using completing the square twice to change something into graphing form. And this is graphing form. The only slight difference is it's equal to 1. And we had to make it equal to 1 by dividing everything by 4. So if you haven't noticed the assignment this week, which was assigned right when class started, it has 2 parts of the book work. The second part is about something called a hyperbola, which is a little bit more difficult, but it is an extra credit assignment. The real assignment just has to do with ellipses. You will see 2 bookwork assignments for this week, and the other half is extra credit. But I will leave it up to you to try to look up how to actually do that, the hyperbola. Any questions about anything? Thank you for being here. Hope you are all doing okay. Well, this is the end. If you all need to go, I've got nothing else. This is the end of the lesson. The content's gonna change as the weeks go. I'm still thinking about what to do after next week of what would be important to you guys as graduating seniors. All right, I will see everyone later if you guys got nothing else from me.